Hey and welcome to exercise number 13. Our goal here is to determine whether for each of these use cases we need to optimize for precision, recall, or F1 score. So let's jump right in and review each use case and figure out which one we need to optimize for. The first one is an ML model to predict whether a certain day is a good day to launch satellites based on the weather. So when figuring out what we need to optimize for, we have to consider the implications of getting a false positive and a false negative. So in this case, a false positive is the scenario where we are predicting that it is a good day, and in fact, it's not a good day to launch a satellite. And the implication of that decision is that the satellite might crash and we would have a disastrous outcome. However, a false negative would be a scenario where we're saying it's not a good day and it actually is a good day. And the implication is that we might have to launch the satellite on a different day. And so assuming that there will always be a good day later, we can conclude that our goal is to minimize false positives. So going back to our formula from the previous exercise, we can see that precision is the formula that accounts for false positives. So that's what we are interested in. So what we can do is check the answer here. And you can see that precision is the correct answer. All right, let's move on to the next one. So here we have a machine learning model that is used to detect fraudulent insurance claims. So once again, go through the same thought process. What happens if there is a false positive? Well, the false positive would mean that we are saying that one instance of a claim is actually fraudulent, but in reality, it's not fraudulent. The implication there is that we end up investigating it further, and usually further investigation would reveal that it is not a fraudulent insurance claim. On the other hand, if there is a false negative, we're saying that an instance of a claim is not fraudulent, but in reality it is. And that's the one that an insurance company would be more interested in watching out for. So with insurance claims, we would be interested in trying to minimize false negatives. And going back to a previous exercise, we can see that the recall model is the one that minimizes false negatives. So our goal here would be to make sure that if there are any instances of fraudulent claims, that they're caught, even at the expense of potentially flagging legitimate claims as fraudulent. All right, so let's check the answer here. And the answer is recall. Okay, moving on to the next one, detecting spam email. With spam email, a false positive means that we've indicated that something is actually spam when it isn't. And what would happen is that a potentially important email might go into the spam folder where the user may not see it. On the other hand, a false negative would mean that a spam email would not be picked up by the filter and would end up in the inbox. And so which one is the worst outcome? Well, the first one is, because you may end up with important emails being dropped into the spam folder that would not be read by the user. And so the goal here is to try to minimize false positives, much like with the first example. And so our goal is to focus on precision. All right, on to the next one. If we're building a model to detect new products that need copyright protection. So say we're a company that produces a lot of products and we want a machine learning model that will allow us to quickly identify those products that might need copyright protection. How would we want the model to work? Would we care about precision or recall? Well, the implication of getting a false positive is that we have incorrectly detected that a product needs copyright protection. And if that happens, we can imagine that there would be some further investigation to examine whether it actually does need copyright protection. And at that point, our legal team would determine that in fact it doesn't. And so the outcome would not be terrible. However, if we have a false negative where a product that actually needs copyright protection is not detected as requiring it, the outcome is that it may not get the protection it needs and the results would be significantly worse. And so this model would be more interested in optimizing for recall to ensure that any products that require copyright protection are detected, even at the expense of potentially detecting products that don't need copyright protection as requiring it. All right, so we're optimizing here for recall. Okay, on to the last one, which is a machine learning model that is used to provide a search engine. And information retrieval applications such as search engines are often evaluated using the F score. And a search engine has to index potentially billions of documents and return a small number of relevant results to a user in a very short time. And typically, the first page of results returned to the user only contain a small number of documents, and users often do not click through to the second page. So it's really important to ensure that those first 10 or so results contain relevant pages. And so the search engine should ideally not miss any relevant documents for the query, but also should not return a large number of irrelevant documents on the first page. And so the F score is used to allow the model to achieve that fine balance. All right, hope that was helpful, and I'll see you in the next lesson. Bye for now.